Hey, so I'm Dan, and
I'm Andy, and we're going to be looking at a couple of hydraulic uh, moving systems or power systems.
yeah,
The first one is a power steering unit in a Volvo,
yep.
and we've got two separate cars that we're going to look at. The first one has prime mover attached, the second one does not, but you will get to see the cylinder in the second one, whereas here you will not be able to see it.
So this is a Volvo 850. It's just a standard kind of car, run-of-the-mill car. Most power systems work like this for power steering. They're driven off of the engine. The engine acts as a prime mover. Typically, there's a serpentine belt that runs from the engine off the crank onto the power steering pump. On this car, it's currently removed, but yes, the engine acts as a prime mover. You can see the pressurized line coming off of the pump, as well as a return line that comes back from the cylinders themselves, and all that's actuated by a set of, well, a valve driven by the actual steering rack itself. And we'll be able to show you that in a little bit more detail once we get to the other vehicle, which is identical in every way, that's in the garage. So, to recap, we have prime mover drives this wheel, which then drives the pump. We have a reservoir right here, conductor, return line.
So here we are in the garage. We've got the rest of the power steering components, including the actuator, a little bit more of the conductors, including some tubing, and we've also got a valve to show you.
So on this particular setup, we have the pump removed, and everything's unbolted from the prime mover, which is the engine, which gives us the nice, easy availability of being able to see all of the conductors, as well as the cylinder and the valve. So this is our cylinder down in here. You can see the inlet on either side. There's essentially a sealed disc in the middle, and then either side has got seals as well. So as fluid flows into one side or the other, that central disc is moved either direction. This assists with your steering. This acts as a valve. It's also the steering rack. So from your steering wheel, there's an inlet up here, and that creates torsion on this bar. And the torsion of this bar changes the way that the valve actuates. So either fluid flows through this line or this line out into the cylinder, which determines the direction of power steering. These are the feed lines. One of them comes from the compressing side of the pump. The other one's a fluid return for the pump. And we can see that some flexible hose has been used here in order for the pump to have some flexibility to be installed and pulled off, as well as flexible hose that is a drain that returns back to tank. And that's about all there is to it. So we're still here in the garage, and we're going to introduce you to the next hydraulic system that we're looking at. What we're looking at here is an engine lift that uses a simple pump style ram in order to lift a great deal of weight. So I'm going to let Andy take over and show you how it operates.
This would traditionally be used to lift a load like a motor when you're working on it. Instead of having a electrically powered motor, we actually have a prime mover, which is me. So using leverage, I can reciprocate the pump, which is right here. That will allow fluid, which is typically housed in tank here, or reservoir here, to be forced from the pump, through the pump, into our actuator, which is our cylinder here. We also have a check valve, which is internal. And that check valve is going to allow fluid to enter from the tank into the cylinder through the pump. However, it will not allow any liquid or any of the fluid, hydraulic fluid, to go back into the tank. We also have a additional valve here, and that valve is going to allow us to return any fluid in the cylinder back into the tank. So when we close this valve, we're able to depress this handle, which will then pump liquid through here into the cylinder and allow us to move our load. Interestingly enough, you'll also notice we don't have any hosing or any sort of tubing specific for conductors. but all of that system is internal. Alright, so we're here in the third video of our hydraulics videos. We've got a pull broach that we're going to be looking at, and Dan is going to explain how the whole machine works, starting with the actuator and moving our way back to the prime mover.
Yep.
Alright, so to start off, this is going to be our actuator. This is the cylinder that we are actuating with the prime mover. Working our way back through the system from the actuator here, we've got a conductor. That hose there is going to lead right to our pump. Our pump is located right here. Just above that, we also have a valve, and that valve is going to be used to adjust the direction of the flow. Now, next to that, we have our tank or our reservoir, and finally, our prime mover, which is an electric motor. And Dan is going to discuss basically how this all works and why we would use it.
Okay, so the way that a pull broach works is you're moving a cutting tool that starts shallow and gradually moves to deeper teeth through a guide bushing that sits inside of the part. So this would sit inside of a part with an ID in it, and the part would be slowly pulled past all of these teeth, and they gradually get deeper and deeper into the part. The way that that functions is that broach is put into this lug here at the front of the actuator. Pump's turned on, and a button actuates a solenoid valve that's spring-centered, 3-position. The default position being return to tank, the other 2 positions actuating the cylinder to either side.